Objective 2, draw and interpret box plots. The 5-number summary can be used to create a graph called a box plot. When drawing a box plot, here are the 5 steps. Step 1, you want to determine the lower and upper fences. So we've done that in the past. So the lower fence is equal to quartile 1 minus 1.5 times the inner quartile range. And the upper fence is equal to quartile 3 plus 1.5 times the inner quartile range, where the inner quartile range is equal to quartile 3 minus quartile 1. And then step 2, we want to draw a number line long enough to include the maximum and minimum values. Insert vertical lines at quartile 1, the median, and quartile 3, and enclose these vertical lines in a box. Step 3, you're going to label the lower and upper fences with a temporary mark. Step 4, you're going to draw a line from quartile 1 to the smallest data value that is larger than the lower fence. You're going to draw a line from quartile 3 to the largest data value that is smaller than the upper fence. These lines are called whiskers. Step 5, you're going to plot any data values less than the lower fence or greater than the upper fence as outliers. Outliers are marked with an asterisk. You remove the temporary marks labeling the fences. So, for example, constructing a box plot. We're going to use the results of the previous example to construct a box plot of the finishing times of the men in the 60 to 64-year-old age group. Recall that the 5-number summary that we ended up finding was 19.95, 26.06, 30.95, 37.24, and 54.63. So, in the previous example, quartile 1 was 26.06, median was 30.95, and quartile 3 was 37.24. So therefore, in order to find the interquartile range, what we would need to do is take quartile 3 and quartile 1. So quartile 3 is 37.24. We're going to subtract quartile 1, which is 26.06, which then gives us 11.18 as the interquartile range. Okay, so it's 11.8 minutes. So in order to find the lower fence, okay, what we're going to do is we're going to take quartile 1, which is 26.06 minus 1.5 times the interquartile range of 11.18 to give us the lower fence of 9.29. And then we're going to take the quartile 3, which is 37.24, and then plus 1.5 times the interquartile range of 11.18 to get the upper fence of 54.01. So if we take a look at our data, okay, remember that if we have an upper fence of, so our lower fence is 9.29, and then our upper fence is 54.01. So what we need to do is determine, are there any outliers? Well, we don't have anything that's less than 9.29, but do we have anything that's greater than 54.01? Well, if you take a look here, this value right here is greater than that. So this one is going to be considered the outlier. So that tells us what the outlier is. So we have one outlier. Okay. So now in step 2, what we want to do is we're going to draw a horizontal number line. So here's our horizontal number line with a scale that will accommodate our graph. Well, we know that we're going to start at 0 and we're going to end at 60 because the largest number is 54.63. So then we're going to put this in increments of 10. Okay. Now what we're going to do is we're going to draw vertical lines at quartile 1, which is 26.06. So right above the 25 mark, we're going to write quartile 1, which represents 26.06. Okay, and then we have our median, which is at 30.95. And then we have quartile 3, which is near 37.24. Okay, and so then once we do that, we're going to enclose these lines in a box. So what I mean by that is, okay, we're going to create a box right above these lines. So this is going to be our box. Okay, and then we're also going to have a line right in the middle that's going to represent our median. And then from here, we can then get rid of the vertical lines that we have created. Okay, so now we have our center, which is our box. Okay, and so now what we're going to do is now we're going to temporarily mark the location of the lower and the upper fences. So where is the upper and lower fence? Well, we know the lower fence is at 9.29. So here is the lower fence at 9.29. So over here, we're going to draw a bracket that's going to represent that lower fence. And then our upper fence is at 54.01. So we have an upper fence at 54.01. So therefore, there is our upper fence. Okay, now again, these are temporary as far as the brackets are concerned. Okay, now in step 4, now we're going to draw a horizontal line from quartile 1 to the minimum value or the smallest data value. So let's locate where 19.95 is. And so we're going to write minimum for our minimum value or the smallest value, and that's at 19.95. And so what we're going to do is we're going to draw a horizontal line from here all the way to the minimum value of 19.95. Okay, and then we're going to now locate quartile, the largest data value, which is 49.17. So here is the maximum value, and that's at 49.17. So we're going to draw a horizontal line that goes from here all the way to the maximum of 49.17. Okay. And so now we know that that number is smaller than the upper fence. Okay, and then what we're going to do is then we are going to then plot any data values that's less than the lower fence or greater than the upper fence as outliers. And those outliers are marked with an asterisk. Okay, so if you take a look here, we found that outlier, and that outlier here was 54.63. And we're going to use an asterisk here. So that means the asterisk is going to be located as somewhere around here, which is about 54.63. And that's going to represent that value. And so now we're going to remove the temporary labeling fences. So we're going to move that fence, and then we're going to move that fence. And there we have our box plot. Now recall that these two lines are called the whiskers, and this is considered our box plot. Okay, next, figure below suggests guidelines for identifying the distribution shape from a box plot. And judging the shape of a distribution is a subjective practice. So whenever you have skewed left, the median is right of the center in the box. So here is the median. It's to the right of the center. Okay? And if you look at the box plot, the left whisker is longer than the right whisker. So that tells you where it's skewed left. So if the whisker on the left is longer than the one on the right, then we know it's going to be skewed left when you're looking at the box plot. Now symmetric. Now the median is in the center of the box. So the left and right whiskers are roughly the same length. And then here we have skewed right. So the median is left of the center in the box. And the left whisker is shorter than the right whisker, therefore it's skewed right. Now, using a box plot to determine skewness. Now, the box plot in the figure below suggests that the distribution is skewed right because the right whisker here is longer than the left whisker, and the median is left of center in the box. We can also assess the shape of a distribution using quartiles. Now, the distance from the median to quartile 1 is 4.89, because if we take 30.95 and subtract 2.06, we're going to see that the distance here, so this is quartile 1, and this is the median. So the distance from here to here is 4.89. Okay, whereas the distance from the median to quartile 3 over here, in this part here, represents 6.29, and we would get 37.24 minus 30.95. Now also, the distance from the median to the minimum value is 11. So if we take 30.95 and subtract 19.95, we know that the distance here is 11. Whereas the distance from the median to the maximum value is 23.68, which is 54.63 minus 30.95. So, when describing the shape of a distribution from a box plot, be sure to justify your conclusion as we did above. Okay, next example. Okay, we want to be able to compare two distributions using box plots. Now, the table below shows the red blood cell mass in millimeters for 14 rats sent into space, flight group, and for 14 rats that were not sent into space, which is the control group. What we want to do is we want to construct a side-by-side box plot for red blood cell mass for the flight group and control group. And then, does it appear that space flight affects the rat's red blood cell mass? So what we're going to do is we're going to open this up in StatCrunch to be able to determine and create these side-by-side box plots. Okay, so I'm going to go ahead and open up this data in StatCrunch. So we're going to pull the data into StatCrunch. Okay, and then we have our two columns. So what we want to do is we want to graph side-by-side box plots. So we're going to select graph and then go down to box plot. And then we're going to select flight and hold the control button and select the control as well. And then what we're going to do is, as we go down a little further, we're going to use fences to identify any outliers, and then we're going to draw boxes horizontally, so we want to check that. We want to locate where the median is. So we want the median, so we know where that's located at. Okay, and then from here, we can then just go ahead and then select compute. So we can enter the x-axis as our labels and our y-axis as our labels. Okay, so we can title this as whatever the title we want as well. So we're going to select compute, and then now we have our box plot. And this is our side-by-side box plot. So now we have our picture of our box plot. And now what we want to do is we now want to elaborate more on this. Okay, so the first one is the control, and the second one is the flight. So here are the two box plots created by using StatCrunch. And it appears that the red blood cell mass has been lessened by spaceflight. First, note that the median for the flight group was approximately 7.7. So that means right here, we can say that the median is around 7.7 for the median. While the median for the control group was approximately 8.6 millimeters. Another thing to consider is that the interquartile range, which is the width of the box for each box plot, is approximately the same. So it appears that the space flight has reduced the red blood cell mass of the rats.